we're going to start taking a look at using these basic rules of inference to be able to either validate or refute more of the difficult argument forms. You might recall in the previous two videos that we were able to use truth tables to be able to verify two argument forms. One of them that we actually verified was the transitivity. So you might recall that all the way back up here, we had P implies Q, Q implies R, P implies R, and that was our transitivity. We also verified P or Q, P implies R, Q implies R, therefore R, and that one's called the division into cases, or sometimes called dilemma. And so what we could do is if we really wanted to prove any of these, just like we did with the basic rules of inference, we could have done that with a truth table. We did that with the logical logical equivalencies earlier. So a truth table really is fundamental to being able to work with our logic. And we're going to see a little bit later in the course, how does this tie in with mathematics and computer science, etc. So we're getting there, but we have to get this foundation of logic first. So one of the things that we can do is we can dissect an argument, write it symbolically, and then determine if the argument form is going to be logical or not logical. So let's go ahead and take a look at a few exercises like that. So we're going to rewrite each argument form symbolically. Then we're going to use the rules of inference to determine if the argument form is valid or invalid. So if Bob answered this correctly, he answered invalid. Bob answered invalid. Therefore, Bob answered this correctly. So let's define P to be the statement that Bob answered this correctly. And let's define the statement Q to be equal to he answered invalid. So we could just say Bob answered invalid. All right, so we have to have those definitions first. If we don't define, then unfortunately, we're not going to be able to get the correct answer out of this. All right? So the first premise is going to say if Bob answered correctly, then he answered invalid. So P implies Q is going to be this statement. Bob answered invalid, so that's Q. And then therefore, so whenever you see the triangle or the three dots in the shape of a triangle, that means therefore or hence. Okay, so therefore, Bob answered correctly, so therefore P. And we're going to go back up top here, and we're hoping that something matches. So we have a P implies Q, but then we have a P, therefore Q. So it doesn't fit the form exactly. And then this modus tollens, we have P implies Q, but then we have a not P and a not Q, or not Q and a not P. And none of the other ones seem to fit. All right, so unfortunately, this is an invalid argument form. And notice that P and Q are flipped. Now, if it was P, therefore Q, we could use modus ponens, all right? This is actually a converse error. Remember earlier we talked about these conditional statements, and only the contrapositive is logically equivalent. So since P and Q are flipped, this is a specific type of error. This one's called a converse error. There's not too many specific errors, all right? But this one does exist because we flipped the P and the Q. Is the converse error. All right, a second example. If I go to sleep early, then I will wake up early. If I wake up early, then I will be energetic all day. Therefore, if I go to sleep early, I will be energetic all day. So let's define P to be the statement, not the conditional statement if, but I go to sleep early. Let's define Q to be the statement, I will wake up early. And then finally, let's define the statement R to be, I will be energetic all day. All right. And notice again that we're not using ifs or thens when we define our statements. All right. So statements they don't contain the words if or then. All right. They're simple statements. So let's draw this out. So the first sentence, if I go to sleep early, then I will wake up early. So that's P implies Q. Okay, I think everybody can see that. I go to sleep early, I wake up early, or if I go to sleep, then I will wake up early. If I wake up early, which is Q, then I will be energetic all day. So it's going to be Q implies R. And then finally, if I go to sleep early, which is P, I will be energetic all day. And that's our conclusion. All right, now we're going to go back up top and hopefully we find something that fits this. So P implies Q, Q implies R. So we have P implies Q, Q implies R, P implies R. And that's exactly what we want. This is the transitivity. All right, so in fact, we proved this one, didn't we, earlier in the previous video? So we're going to say this is valid by transitivity. All right, and again, two things we have to have before we can make a conclusion. We have to define each of the statements, so we can't just draw this up without P, Q, and R. So we have to have both of these to be able to substantiate our claims. A pretty easy one. Homer works at a power plant and sleeps on the job, therefore Homer sleeps on the job. I mean, it seems pretty logical that if he does both things, then he does one of them. We're going to define P to be equal to Homer works at a power plant. And let's define Q to be the statement Homer sleeps on the job. All right. And if we draw this symbolically, Homer works at a power plant and sleeps on the job. So this would be P and Q. And that should be an and. So we have P and Q. And then therefore, Homer sleeps on the job. That's Q. Okay, so we have P and Q, therefore Q. So let's go back up top. So we have P and Q, therefore P, P and Q, therefore Q. And we have a winner. So that one's going to be specialization. So we can say that this is valid by specialization. All right, and again, we have to have the definition for P and Q, and we have to have the logical form. So logical argument form. All right, so hopefully that helps you to understand how we can start using what we learned earlier with the truth tables to apply it. Now, in the last section, what we're going to do is we're going to start taking a look at how do we use the rules of inference to be able to verify longer argument forms. And it might be helpful for you to go into Blackboard and print this worksheet out, all right, because we're going to be using these basic rules of inference, and they're going to be useful to have rather than having to flip back and forth to the one page that's in the guided notes. All right, so we'll do that in our next video, and we'll conclude this one.